No what? Mumbling?
No swearing.
Well, can't guarantee that.
Right. Welcome back to another edition of the BIMTech podcast. Been a bit of a long time in coming, this one, because today I'm joined by, for anyone who works closely with BIMTech or clients or whatever, probably doesn't need much of a introduction, but it's the legend that is Mark Cain, otherwise known within BIMTech as Yoda, as he's a bit of a fountain of knowledge.
Well, you know,
and he's also our Manchester BIM manager. So got Mark here today. I've done a bit of an introduction for you, but I don't know if you want to.
No, I mean,
say anything about yourself. Big yourself up.
No. To be honest with you, I would to mention about the fact why we knew each other. You know, and as much as that, you know, we're probably boring people to death with all this.
You're throwing me under the bus now, aren't you?
I'm going to throw in the bus, yeah, mate. So basically, me and Matt were apprentices at a ductwork company in Harpay, Manchester, when we were 17, 18, and we were dragged up doing ductwork, weren't we, mate? And
we certainly were.
Yeah, and anyway, that company went bump, and we kind of separated ways. And about how many years ago now? Probably 12 years, 13 years, something like that.
Yeah.
We joined forces again, and never looked back, really, have we? I suppose.
Here we are today.
You know,
who thought back then we'd be sat doing podcasts?
To be honest with you, mate, I didn't think I'd ever stop using a drawing board, so I'm not really one to talk. So there we go.
Yeah. So today, anyway, we're going to just basically talk about quite a large project we worked on. Well, we completed it in 2019, so I think it's safe enough now to talk about it. And we're just going to talk about some of the sort of pitfalls on the project and reasons why sort of BIM sort of was the tool that helped us to deliver it so successfully. Yeah. So the project is Scalpel Tower in London, otherwise known as 52 Lime Street, and it's in the Bank District of London, and it's quite an iconic building. It's opposite the Gherkin, and I don't know why it was called. Is it meant to look like a scalpel blade or something? Is that why it was Scalpel Tower?
To be honest with you, I can't always remember why it was called.
I think that's what it was, wasn't it? I think
because it has got like this weird kind of iconic.
Goes to a bit of a
to a point,
sort of like a blade at the top, isn't it? So I think that was the idea of it. Yeah, the scalpel.
Yeah,
I think there was about 40 floors of office space.
44, and then 47 up to 50 something.
Yeah, there was a few floors of plant at the top, but they were quite awkward because the footprint went a lot smaller, but it was very narrow, and there was a lot of steel work in there and everything. So that was quite a complicated area.
Yeah.
Then you had the ground floor, which was more like a reception, and I think there was a loading bay within it and things like that. And then we had 3 levels of basement.
Yeah.
B3. The lowest basement was like concrete water tanks, weren't it?
Yeah.
Sprinkler tanks.
Yeah, the sprinkler tanks. Then main level up, and then another one up,
and then,
from that as well.
Yeah. B2 was the sort of the main plant areas.
Yeah.
Where you had a lot of the sort of switch gear and everything.
Yeah.
And then B1 was more like back of house areas, weren't it? With showers and
the cycle store and things
changing
like that.
areas, all that sort of stuff, and a little bit of plant as well in there. But that sort of summarises the building. I think the idea was there was a main client, and his intention was to take a few of the upper floors himself, and then was leasing the rest of the building out. So again, it was one of these projects where, like a lot of projects these days, where the project had to be finished on time because there was going to be a lot of costs if the project overran.
Yeah. Well, it didn't help that the guy who actually paid and owned the building was like right at the top one. Do you remember? He had two top floors.
He wanted the penthouse, didn't he, for himself?
I think we built an atrium for him, didn't we? So there was an atrium that kind of.
I remember it was all soundproofed walls around it, and there was plant above his office, so it was all on springs and everything spring loaded. Yeah, I remember all that. Yeah. So anyway, what we was going to do was just talk a little bit about some of the sort of like, I don't know, like the problems we had to overcome. I think some of them are fundamental problems that you get in London all the time. Like I think what you tend to get, or what I find, is generally in London, especially in the bank area, the buildings are very tall, but the footprints aren't necessarily
small, aren't they?
As big as you would expect. And the reason being is obviously land and that is a premium in London. So things tend to be a bit smaller. The other thing is they try and utilise whatever space they have got, they try and utilise it so there's not a lot of outdoor space around. So
I think, if memory serves, I think it was something existing, like probably most new construction near the centre of London, that there's always a building comes down first before something goes up. And a lot of the buildings, the shape of them and the footprint, it's all dictated by surrounding buildings and roadways. It's
because of that, one of the issues is that externally of the building, there's not much storage area. So what we found is there was, as we were doing coordination and everything, and when we were visiting site, we did visit site quite regularly, that a lot of the space where things should be getting installed were being used as storage areas. You walk down the corridors and the corridors were a bit, I don't know, just a bit,
it was
fuller than I thought on the floor level for storage and trying to get scaffold towers around them and different things.
Didn't they have some of the office space there as well, if I remember right, towards the end?
The site offices.
The site offices and stuff were there as well.
I think some of the area turned into, because like you say, I think especially for the site teams and that, where they want to store all the materials and everything, I think that all did end up moving into the sort of basements.
The basement areas, which again is just something else to avoid, or something else to work around.
I think it all becomes a programming issue, doesn't it? There was areas that we knew later on in the project would be congested with materials or whatever. So it made it probably more awkward for the guys on site, but for us, it was stuff worth knowing. Because it did change a little bit of how you would coordinate services, certain services that you'd want to keep out of these areas, because like the HV cables, because it's a continuous cable and you're not stopping and starting with the install of it. It's got to be done in one hit. So if you know there's an area that you can't get into, you've got to avoid that. So it was things like that, I guess. And like I say, and the corridors, I remember walking around site and felt sorry for some of the guys when you saw how cluttered some of the corridors were. But again, that was more of a site issue. But then going on to, I just mentioned about the HV cables. Don't know. Well, I'm sure you have got thoughts about it, because I remember one of the problems. It was actually pretty comical. Really, the
usual thing. It was diverse routing. And there was also fire protection, wasn't there? They went for Kenwell, was it? Was that the product they went for?
It was. I think it started off, they were going to go for that Durasteel.
But I remember it was at the slab. And it wasn't, and it was up and down. And if I recall, was it because of the weight of the drum at one point and the continuous cable? Wasn't it?
I remember sitting in meetings with this. So HV cable, you tend to try and get it in as the highest service. You tend to fix it to the slab, and then you put a 3-sided box around it and
to protect
it from like fire or anything else. But in this instance, we couldn't put it as the highest service, because what you tend to do is you put it in and then you forget about it. But like I said earlier, you have to run the HV cable from start to finish. And because the start of it was in the basement and the finish of it was going to be up at sort of level 40 or 44 or whatever it was, it had to be a continuous cable. Well, it was tri-cables, wasn't it?
That's right.
So it had to be these 3 cables going diverse routes had to get up to that level, and it had to go in one hit. So as soon as they started putting the cable in, it had to go all the way. Otherwise, they had to have it on a drum somewhere stored. And because the cable was that heavy,
they couldn't store it,
when they did the calcs, they had nowhere to store it, because the slabs at like ground floor and first or whatever could not physically take the weight of the coils of cable. So because there was nowhere to store the cable, they said, the HV cable, as unusual as it might be, has to go in last. So we had to come up with a way
that was a way of
getting it in as the lowest service, which is quite unusual.
Well, it was something that we were, part of the way through the coordination, certainly in the basement areas that I was doing, and all of a sudden then it was like, well, actually, no, this thing can't be tucked up against the soffit and out of the way. It's got to then come down, and then it's access after. I think, was it a 3-sided Kenwell that we went for? That was,
I think it had to be 4-sided.
No, I'm saying, but they only installed the top and the sides, left the bottom out. Cable went up, and then obviously they finished the bottom. But yeah, it was.
Well, the other thing I remember as well was, because normally, like again, if it's up against the soffit, if there's a fire or anything below, and the services all collapse, it's at the slab and it's safe. But when it says the lowest service, it wasn't just making the Kenwell secure that the Kenwell was the fire protected box. It wasn't just making that so that wouldn't fall down under fire conditions. It was making sure it could take the weight if everything collapsed and landed on top of it.
Well. Yeah.
So we ended up, I remember there was like a bit of a subframe that went above the top of it. So if anything fell, it landed on top of the subframe rather than on top of the HV cables. Yeah. So that was a big issue on the project. So, but I think probably enough about that now, because people will be bored. I was nearly swore then. So I'll leave that for you. So the other thing, I mean, I know some of that was a bane of your life on that project, was the slab loadings. Yeah, so
basically what it was, I was nearing the, not the end, but I was nearing to a point where, majority of service are in, we settled on, the layering of it. This is the B2 basement. And the main water plant room, which had all the major chilled water heating pumps, all the domestic plant,
and that pipe work was big. I mean, the chilled water was like 250 diameter, wasn't it?
300 dia, some of that is. The plate exchangers were something like 2.5 meters tall. I forget the weight of them, but they were colossal things. And basically, we were being told, we did pump skids and the plate exchanger skids, but pretty much everything else was traditionally installed from the soffit above. And out of the blue, towards the end of modelling, somebody raised the question about, has anybody checked that the slab...
I remember being sat in a meeting when that got raised.
I bet you were sat there saying, I've got to go back and tell Cain all this one. He's just going to lose his head. But so basically what they realised is that the structural engineer had basically calculated the floor load of the floor above just to take what was there, and basically it was just toilets for, I think, the cycle store or something like that. I think it
was the shower room.
Shower room, something like that. So they realised quite late on that, in actual fact, that slab above the plant room couldn't take the building services that we thought were being suspended off it. And right at the end, we got told then that the whole of the plant room services had to be basically supported off pedestals and framework and steel and goalposts and everything. And to be honest with you, I remember at the time it was like you thought that it was just going to be an absolute trauma. But to be fair, because I think I decided early on that I was going to leave a decent zone for drainage, because I think we had sprinkler mains at high level and a lot of drainage and what have you. And we had a lot of crossovers and at the time, more luck than judgment.
Don't say that.
I know, yeah. I left quite a decent zone at the top. So don't ask me how, but we managed to shoehorn in without too much alteration to the MEP services. Is that, like say, all that steelwork and goalpost, but it was
you almost created like a steel framework box, didn't you? Yeah. That fitted in the plant room first, and then all the services fitted within that.
Fitted on that, yeah. But there was a lot of gear in them plant rooms. Hell of a lot.
And then talking about the plant rooms, and another thing that we did do quite a bit of was the DFMA. So the prefabrication.
Yeah, so
but it was mainly just plant, wasn't it? We didn't do much on distribution for risers.
Yeah, it was the risers were DMFA, but the in the plant rooms it was mainly pump skids and the plate exchanger skids. But again, when we're saying there about the plate exchanges being like 2.5 meters and the weighed an absolute ton, again, it was logistics of how them things move through from where they get lowered into the basement. You know, I think we had I forget the technical term for it, but the wall down plan. So there was certain walls that couldn't get built, and it's like I say, it's logistics of where they get dropped down. And then we had restrictions then on sizes of frames.
I think if I remember rightly as well, there was like a location in the ground floor where there was going to be an opening left in the slab to drop down into B1.
Yeah.
But it wasn't directly above the hole down to B2.
Yeah.
So you'd have to drop it down to B1, then move things around B1 to get to the hole that dropped down to B2.
Yeah.
And then move back around again to get into the plant room.
Yeah.
So there was quite a bit of planning to be done on that with head heights and everything else.
And that was the other thing, wasn't it, is because your skids virtually going last, as it were, because, you know, you want to be installing all your high level services. You don't want plant skids below
you don't want to be clambering over the top of it, do you?
So, you know, again, that all has to come into play about, you know, you've got to think about how these things get skidded in after all the high level services have gone in, and have you know, got the logistic path for doing that. And
you also have to look at, which I know it's going to sound obvious when I say this, but when you're in the mindset of modelling something in 3D and you're putting in its final position, when you've got it on that skid frame, it's sat on the floor. When you're manoeuvring it to get it into position, it's going to be on some sort of wheels. Yeah. So it's going to put an extra maybe 6 inches or 8 inches on the height of it.
Correct. So that's again, but when you're doing all this skid work, that's what you do have to consider is that, you know, the skids will raise up so far, and then you can have jacking points. Sometimes you can have AVMs as well. So again, you have to think about all these things about, you know, what space and you need to actually move this thing isn't necessarily its finished level, you know, when it is dropped in position. But it is. You just got to think about everything involved, don't you?
It's like, it's just jumping onto the risers here, because that was, again, we did quite a bit of DFMA on that. And I remember one of the things early doors was it was anchored at the basement, and then everything went upward. So any expansion, the riser grew as it went up. Yeah. So when you go up a couple of floors, you're only talking millimeters. But when you're going up 10, 15 floors, it starts coming into, it can be like 50, 100 mil or whatever, the sort of distance when it starts to expand. And I remember us having to actually work out, well, on this, like one of the upper floors, when the building's operational and everything expands, the branches are going to move by, say, 100 mil. So I think we actually physically moved the riser module up 100 mil and reran the clash dissections, because we said when it's in operation, that's where the branch is going to be. It's not going to be where it is now in a sort of.
I think we had to. Did we have to do some sort of calc, or somebody did some sort of calc with the cold draw as well and the chilled?
Yeah.
So your heating's expansion, but your chilled is contraction, isn't it? You know, so I know that
they said they don't normally worry about chill water, they don't, they said because it was such a long
big
distance,
and such a high building. I'm sure that
I think it was because of the diameter
done.
of the pipe as well.
Yeah,
because it was such large pipe work.
But while we're on the subject of them rise, obviously, you know, we're about the anchor point in the basement.
Yeah, it was a bit of a faux pas there.
It was, yeah. So, but if I remember right, we came down.
It wasn't so much the anchor; it was the dirt pocket at the bottom.
It was the dirt pocket that was the problem. So there was a branch, there was a dirt pocket with the IV and everything else. I think possibly, you know, 50 mil stab off with an IV drain. So basically, what they said was, well, what we'll do, we'll flange all that. We'll have a false piece of pipe, a steel pipe down to the actual basement floor level, and we'll use that as an anchor point then for the expansion of the riser. And then again, something that we didn't consider was the actual valves involved, wasn't it?
Yeah.
And they realised that the forces involved on this valve at the dirt pocket, basically crushed the valve. So then there was another secondary cantilever fair wanted back to the shaft wall to actually take some of that strain off. So yeah, that was again that was another steep learning on that one.
Yeah. The other thing I remember as well, again, like what we were saying about with the footprint being fairly small, there was so much plant down in them basements, but because the footprint wasn't massive, I remember like the distribution corridors, like it's a basement, so there isn't a ceiling in there, but if you imagine a ceiling at maybe 2.4 meters, above that level up to the slab, you had about 2.5 meters to get everything in. But what it meant was your corridors were fairly narrow, but very tall, the space. So the logistics of getting all the services in and being maintainable afterwards was a bit of a nightmare, weren't it? Because
again, you've got to think about, first of all, what services do you want at the top that's going to have limited access? But the fortunate thing is that 9 times out of 10, one of your top services is your drainage, and then you've got to consider about the rodding eye points for that. And I remember we were extending on the Ys with the rodding eyes, we were extending that rodding eye to a clean spot, weren't we? Where you can actually get up to and actually rod through. So it wouldn't necessarily be on top of the last Y connection. It'd actually be where you can actually get up to it. So and it was a case of layering from the top, and like say going back to the HV with the Kenwell, that chucked quite a big span in the works towards the end, wasn't it? Where all of a sudden that had to come down, and you had to consider that for the access. But
the other thing I remember with the corridors was we ended up using Trimble field points.
Yes,
because we realised there was that many different sprinkler systems at the top.
Yeah.
Like there was almost a blanket of sprinklers down the corridor, and they were like main distribution pipes, so they were quite big. And we said once them pipes go up, no one's getting back to that slab again to drill it.
Yeah, so it was all as the trades come lower and lower in that corridor, it's
how do you get back
access
up?
to the slab just gets more restricted.
So the idea then was using Trimble field points.
Pre-drilled,
you can pre-drill all the slab and get all the anchors already installed and a bit of rod or whatever.
They were putting all the rod down, weren't they? Which the rod was there then for all the other trades to connect onto. So that was, it was a good solution for what could have been an absolute nightmare. What I did think was good on this particular project, especially for us, was that they actually had somebody doing like a stage 5 architectural model. So they were putting all the, like you say, lintels in. They were all getting modelled in. Even every single hole we requested got modelled in. So there was a hole there. So when we could run a clash detection, it was.
If there was a pipe going through a wall, it wouldn't come up as a clash because there's a hole there and it goes through the hole. A lot of the times when we work now, we never get that detail of architectural model. So you run a clash detection and it'll come up and say your pipe's clashing with the wall and blah, blah, blah.
You have to basically just discount them because, the hole's not there to be formed. And all that we can do going forward is believe it or not, is, a clash detection against our own builderswork sleeves. And that's. But
it was a great way of seeing if a builderswork opening had been missed.
Yeah.
Because if it had been missed, it'd come up as a clash because it's there's no hole there. So it was a very quick way of running a quick clash detection and seeing whether any holes had been missed. But like I say, I think it's few and far between we get, apart from the main structural concrete, like your shear walls and that, people tend to model in the openings in them. But when it comes down to block work and studding, it's very rare that we get
the
architectural
thing,
models.
Yeah, and the thing is, you touched on there with drywall, plasterboard walls, in as much as that, we have to account for king stud arrangements that aren't there for us to physically miss.
Yeah,
sometimes, and having that work interface with architects, with your fire stopping people, with your fire damper people, with British gypsum and everything else. There's a lot of individual elements there that need bring together, and not to blow our trumpet, but we're kind of like the interface to bring those people in. And there's a lot of contracts now where, from a builderswork point of view, a lot of the rules have to be set out really early. And, I'll completely admit that years ago, I'm sure you'd agree, that the builderswork almost went in at the end to a point, because we've seen that as, well, what's the point in putting builderswork when all the MEPs got to go to construction, all your holes are going to change anyway and everything else. Whereas nowadays, one of the first things that we actually establish and even model in is the builderswork.
It's almost dictating the coordination now, isn't it?
Yeah. The thing being is, though, there's still differences out there, which, it isn't worrying, but it's just a fact of life that, people can interpret different rules and regs, but, ultimately, it's one of them things now on any project that, I kind of, push the client into setting out them rules so that, again, it's getting people on board that wouldn't normally be on board at early stages in the job, but it's very important that they are. And as I just said before, it's your fire damper people, it's your fire stopping people, it's your walling contractor with British Gypsum, and it's bringing all them people to say, right, what rules are working to? Because you have deflection zones as well, don't we, in dry walls, where there's the building tolerance, there's settling of buildings, there's expansion during fire, where something needs to be allowed for that as well. And there's a lot of moving parts that I don't completely understand, but I know what effect it has on building services.
Yeah, well, I know, like, if a slab deflects by 25 mil, for example, I think you have to allow some of the build up of a plasterboard wall. You have to allow about 250 mil for it to be able to compensate for that 25 mil within it, without it then deflecting onto the actual builder's work opening. Yeah,
I mean, we've had all sorts, haven't we, over the past few years, and say fire damper holes, obviously that they have to be in their own separate holes, but separation of holes, should we say, between services or the fire dampers. We've had everything from 100 mil to 200 mil to 300 mil. There's a lot of difference out there, and it's pinning someone down to say, right, what are them rules? And to be honest with you, they need to be cast in concrete, because there's quite a lot of jobs where even when you've gone to that diligence of actually producing those rules, you get, somebody comes on board, a new walling contractor or a new reg change or something like that. And those kind of things, the amount of times even nowadays that, the amount of change that we have to go through because of...
I know this one you'll like, though, is that sometimes there's that many different rules, you can't achieve everything.
No, exactly.
And somebody will come up with your favourite saying, engineer's judgment.
Oh, it's just, it frightens me. It frightens me. When them words get used, all of a sudden it's with all due respect, you're not going to...
Well, it's like, who's the engineer? And why is their judgment
and
acceptable?
It's just...
And then you find out further down the road that it's not acceptable.
Exactly. Oh, we've had plenty of jobs where the easy get out is the engineering judgment, and I've said that unfortunately I'm telling you now it will not happen, because you're asking for somebody to basically put their name on a piece of paper to say, that wall in that circumstance will stop a fire. And I'm sorry, in this day and age now, that's just not acceptable.
Unless it's been tested.
Yeah, exactly. Yeah.
I remember with one of our clients, I won't name it, it was a good thing actually, but I'm still not going to name. They give me the opportunity to sit down in front of their sort of buying department and explain to them why we need what we need and when we need it.
Yeah.
And we would say, just about, say, a pump, for example, and I was trying to explain to them why we needed that information to be accurate. And I said to him, I said, just imagine we're installing it. I said, just think of it that way. I said, because I said, we are in a virtual world installing it. I said, so if you had somebody on site going to install that pump, I said, could you tell him it's one of three?
Yeah.
One of three manufacturers we're going to go with. I said, he wouldn't be able to install it. He needs to know the exact pump that he's installing. I said, and we need to know the exact pump that we're modelling and putting in. I said, because otherwise it's not going to work. And when it comes to site, it's not going to fit.
Especially around, DMFA areas of work. I mean,
Well, yeah.
you know,
When you work into the millimetre.
it's either accurate or it's wrong.
Yeah.
There's no tolerance. There's no in between.
No.
It's either right or it's not going to work when it's put together. You know, and there's a lot of moving parts. Like I say, there's a lot of things that I wish would be sorted out early. CDP elements work. Sprinkler designs and things like that. Even what we tend to do, as you know, is that we. If we're coordinating servicing, albeit, coordination design of the sprinklers isn't necessarily in our scope, we still have to allow for that. So invariably, we will always allow mains and such like and systems of how branches can come off. But again, it's one of them elements of work that seems to be brought on board very late in contracts that then, we have to either work around or, because all due respect, we're not sprinkler experts. That's the reason why these guys are brought on board, because, they got the expertise and such like. And again, just all late engagement that,
But if I was to wind this up now, and I said to you, just to finish off, what is, as somebody who coordinates building services, creates the 3D virtual models, what is your 3 biggest bugbears that you have to
3 biggest bugbears
with?
Is builderswork rules, getting set in concrete early days, procurement equipment, and even simple things like, the valving with the databases and the insulation, the materials and everything else, is that everything is set early days and in basically as robust position as it can be. And then further on down the road, like say, there's less change, there's less waste, basically, time and money, all because, I mean, I understand, if you need a pump set, a year down the road and we start work, that's the mindset. It's, I don't need to sort that because I don't need it yet. And it's like, yeah, but we need it because you're asking us to coordinate, So that's the big things at the minute.
Right. Well, thank you very much for that.
No, it's all right. Been a long time coming, hasn't it?
Yeah. Hope you've given a few people watching a bit of an insight into the sort of trials and tribulations that face you every day. I
don't think there's too many bleeps, is there, mate?
I don't think there was any, actually.
Just one? Fucking hell.